Hello everyone and welcome to today's video. Cross-origin resource sharing is simply adds flexibility to the same origin policy. Same origin policy instruct browser to not allow access to resources across different origin easily. Here the resources can be HTML page, API response, JSON data, etc. Remember that the full control is on browser level, means request will hit to the server but we can't see the response. But if we intentionally want to share resources with other origin, then we need to loosen up the SOP, which can be done by CORS. So CORS basically is cross origin resource sharing, which is used to bypass the SOP with CORS headers, is a more secure way of allowing cross-site interaction. That's how messenger.com access context from facebook.com. Here is one example. We will deep dive into what is actually CORS and what are the headers is the we use to bypass the SOP. So CORS header are set by the response server and are verified by the browser before granting access. Those headers are access control allow origin and access control allow credentials. These headers are set by response server. Here in this case the response server is foo.com. Let's consider this example. We have a site called example.com going to make a request to foo.com. Then course header has to be set by foo.com. But in this case, course headers are not set by the server, so SOP will block the response. Remember that request will executed by the server and send the response, but course header are not set by the server, so SOP will block the response and it's not readable by the example.com. So if foo.com wants to share context with example.com, it need to set the course header. Here in this example, the course header is access control allow origin, which is example.com. If foo.com want to share contacts to example.com, then foo.com need to set his own course header access control allow origin. So if in response browser see the this header, it will allow example.com to access response from foo.com. But it's simple, it is seems, but there is one catch. The catch is related to cookie. Suppose let's consider example.com requesting contacts from foo.com and consider it's an authenticated request. Here it's an authenticated request. So example.com has to send credentials as well to foo.com to know from whom the request is coming from here, and credentials could be cookie, token, etc. So here that it can be anything like a cookie, token, anything to know the server from where the actual request is coming from and it's actually authenticated or not. Suppose example.com running some JavaScript code. It has to send credentials as well to the to foo.com. This is done by setting credentials is equals to true while making a XHR request, as here is using a JavaScript code. And if server accept the credentials and the response come in as was coming in the previous case, response again be blocked by the browser. So in the previous case we have that only access control allow origin is set. So it's the same response the browser receive, so that will be blocked by the browser. Here, as the response want, as a browser want the server foo.com to confirm that credential can be set from the example.com. That confirmation is still not received by the foo.com. So, in this case, browser want the server foo.com to confirm that credentials can be set from example.com site. That confirmation is made by foo.com by setting access control allow credentials is equals to true. When browser sends authenticated request, SOP will block it if response do not contain course access control allow origin header. So that's where we have to send that specific header in response. Foo.com has to set access control allow origin header, then browser allow example.com to see the response. Thank you so much everyone. I will see you in the next video.